Okay, now in the last video you took two equations, graphed them, and found the intersection point. But we saw specifically on there was an example where I wrote abort. Sometimes you can't see it. The graph's just simply not big enough. So graph, and also sometimes I can't really see the exact point where they intersect, particularly, especially if it doesn't hit the grid. So there are other strategies to coming up with a solution point, the solution that works for both the ordered pair. And what we're going to be learning today is known as the substitution method. So I'm going to write this, and I'm going to be using that term a lot. Substitution method of solving systems of equations. Okay. Again, it's a system. It's a system of equations when we have more than one equation, more than one variable. That makes a system. That constitutes as a system. Okay, so what I do is I'm going to make my coordinate point here, x, y. You're like, well, how am I supposed to find that? You don't have a graph. Well, you're going to, instead of using the graphing method, you are going to employ the substitution method. Now, substitution method works best if I can find a variable that has no operations with it. So that x has a multiplied by -5. It also has a plus, and the y has a 3. So that there's no variable that's void of any operations. But how about this y? That has no operations. So what I need to do is I'm going to box up the y, and I'm going to circle what is on the other side, what the y equals. Okay, now here's what I want to do. That's known as what I call, I made up this term, this is known as our base equation. Okay. Now, what I do is I take the opposite equation over here. I write the non-base equation, -6 5x plus 3y equals 51. Okay, now when you wrote your non-base equation, the opposite equation, the off-base equation, you want to make sure each variable has a number in front of it, a coefficient that has -5, that has 3, okay? You also want to make sure any subtractions become plus negative, but we don't really have that problem here. Okay, so here's what I do with the off base. Whatever letter didn't have any operations, whatever letter, in this case it's y, I am going to put parentheses the y and empty it. So -5x plus 3 parentheses equals 51. And in that y, we're going to put what y equals. But we have a little problem. Y equals more than just a single value. It equals an expression, 10 times x minus 8. So let's widen the parentheses. -5x plus 3, widen our parentheses, equals 51. Okay, now, and we're going to put that expression in there, 10x minus 8. Okay, make that plus negative. Now, we need to do a distribution with our 3. 3 to 10x, 3 to -8. Okay, so 3 multiplied by 10x is 30x, plus 3 distributed to -8 is -24. So that's the product there. Now, we have to add a -5x, because that's there, before I write equals 51. You got to remember to add that term right there. Okay, now I have two x variables, but they're on the same side, and I can solve for x, so they're on the same, so I'm going to make my little adding pyramid. 30 plus -5, it's like 30 minus 5, that'd be 25x. And then I need to add the -24 before equaling 51. Okay, combine those, that, and that. Okay, now I just do the x being multiplied by 25, but I add 24 first. Okay, so 25 times x equals 75, and then I divide by 25, divide by 25, and that's the x. You got to pay attention to what letter that is after you've divided. It's x that equals 3. So I put a 3 for x. Now, here's what I do after that. I need to get my y value. Well, let's use the base equation because the y is by itself. All I need to do is replace x. I already have my answer for x because y equals, think logically about it. I need to solve for y. Well, y equals 10x minus 8, but I have my answer for x. So let's just replace that x with 3, and we can take 10 times 3 and then subtract 8. Okay, it's really easy. You can just do order of operate. 10 times 3 minus 8, 22. So y equals 22. So 322 is the solution to that system. Okay, the next equation. Remember, all equations I'm finding a coordinate, the coordinate point where the lines cross. In other words, the solution for x and y that satisfies both equations in my system. Okay, now I need to find a variable that has no operations with it, that is all by itself. So look at where your equals are at. That doesn't have any operations. That y doesn't. Now you're like, well, neither does the other y. Yeah, it does. It has a plus with it. It's not by itself. Okay, y is by itself. So again, I use the substitution method. I'll put sub method. Now, this is my base variable. Okay, because that has no operations with it. So I box up the variable and circle what it's equal to. Now this is the off base, right? The off base equation over here. 3x plus y equals 10. Now again, when we use the substitution method, when I write that off base equation, you got to make sure both x and y have coefficients or this is going to be a nightmare. X has a 3, y has a 1. There are no minuses that I would need to make plus negative. Okay, so remember, y was my base variable. That was the variable that had no operations with it whatsoever. So I parenthesize the y. Then I just empty that parentheses. 3x plus 1. Write everything else the same. Equals 10. Now, what's y equal to? It's equal to the expression 2x plus 5. So that's what I'm going to put in place of the y. But I need a wider parenthesis so I can fit both terms, 2x plus 5. Now at this point I have x twice in the equation. That's a good thing. As long as I have the same variable twice, then I'm on the right track. So I distribute 1 to each of these. So that gives me 2x plus 10. Then I need to add the 3x, then equals 10. Okay, now my x's are on the same side, so we add those. 2 plus 3 is 5, 5x. And then we need to add the 10 before I equal the equation. I equal the 10. So x being multiplied by 5 here, so I need to minus 10 from both sides. And 10 minus 10 is 0. Some of you are like, oh, all solution, no solution. No, it's not. My x variable is still here. It's being multiplied by 5. So we divide by 5. 0 divided by 5 is 0. So x equals 0. So x is 0. Then to solve for the y, let's go into the base equation. We already have our answer for x. We just found it. So read that to yourself. Y equals 2 times 0 plus 5. Well, 2 times 0 is 0, and 0 plus 5 is 5. So 0, 5 is the solution to that system. Okay, we're going to keep it rolling here. Okay, a little bit of a difference on this one. Here's the variable that has no operations with it, okay? So again, substitution, but this time the x is my base variable. So let's box it and circle what it's equal to. Okay, now let's write the off base equation. 2x minus 3y equals 1. All I'm doing is taking the off base, writing it over here because I'm going to do some work with it. Okay, now x is the base variable this time, not y. So I parenthesize the x, okay? Not the y. The y wasn't my base variable. So 2. Empty your parentheses. You got your minus. Oh, yeah, one other thing. You need to make sure that's a plus -3, or you're going to end up with problems. Okay, x had a 2, y had a 3, but the minus, we want to make that plus negative. So I keep the y. I'm not emptying the y out. Okay. No, so that's, we're going to solve with that. Okay, so we need to make this a bit wider because x equals more than just one value. It equals an expression. 6 subtract 4 times y. So we need to make that a little bit wider. And I will be putting 6 minus 4y. Now again, let's make that plus negative. Now, when we do the distribution, 2 times 6 is 12. No y on that, but then 2 times -4y would be -8y. Now remember to add your -3y before the equation equals 1. So this time I have matching y variables. Y appears twice, and that's not a bad thing, okay? As long as what you don't want, you want to make the equation so you don't have an x and a y. So you have two variables that are the same, because I know how to solve linear equations with those. Okay, y's are on the same side, so we do the adding. -8 plus -3 is -11y. Then I need to add the 12. We can't forget the 12's there. Equals 1. Okay, so y is multiplied by -11. I subtract 12, subtract 12. So -11y. 1 minus 12 is -11. Now we divide by -11. Now -11 divided by -11 is 1, but you got to keep in mind it's y that equals 1. So I will be putting the 1 under the y. So to solve for x, let's go to the base equation. Okay, that's where I have x without any operations with it. So it equals 6 minus 4y. Well, we have our answer for y. Y is 1. Okay. So we have 6 minus 4 times 1. Well, 4 times 1 is 4. 6 minus, and you, by the way, you can just use your calculator because you don't have to undo anything. 6 minus 4 times 1. I think it's 2, but yeah. So 2, 1 is the intersection point. That's the solution. Okay, now this one. This one is like up to you as to how you want to do it, because you see I have two variables without any operations, the x here and the y here. So it doesn't really matter. I can use this as the base equation or this one. I guess I'll go with my top one. I'll call that the base equation. So what's your variable equal to? The expression y plus 3. So this is going to be my off base. So let's write that. Y equals 2x minus 5. Okay, now one thing, when we're doing the substitution method, that's what you're learning in this video, the substitution method. When you write the off base equation, you need to make sure both variables have coefficients. That has a 2, that has a 1. And any minuses we make plus negative. So x is my base variable. So that is the variable I'm going to parenthesize and replace. Whatever variable I have isolated in the base. That says base, B-A-S-E. So I have 1y equals 2. Let's empty the x because that's getting replaced. Now x is replaced with the expression y plus 3. So 1y equals 2. Let's make that parentheses a little wider. And we're going to put 1y plus 3. So we can write 1y equals. We don't really have any operator, plus or minus operators over there. And over here we distribute. That's going to be 2y. That's going to be 6. And then we add -5. Now here we have matching y's, but they're on opposite sides, so we can't add. We have to balance the equation. Let's take the y that's over here. Because if I get rid of the 1, there's not going to be anything there, and I'll get confused. 1 minus 2 is negative 1y. And over here, these are like terms. That doesn't have a variable. That doesn't have a variable. They're both constants, and you can just add those together. They're on the same side. They're like terms. 6 plus negative 5 is 1. Then divide by negative 1. That's negative 1. Now that is my y value. Okay, you got to pay attention to what the variable is at the end. I have a lot of people that put that in for x. Okay, now solve for x. Now go into the base equation, the one right here. And we already have our answer for y. So y is negative 1. Just do the only operation you have to do, negative 1 plus 3. That would be 2. It's because x doesn't equal, x now equals negative 1 plus 3. Well, negative 1 plus 3 is 2. Okay, so x is 2. So 2, negative 1. All right, the next problem you really can't do, okay, because there's only one. I don't know what I was thinking there. Okay, again, the goal is to find the xy coordinate that is in both lines. The one solution that is common to both solution sets. Okay, again, we have a x without any operations and a y without any operations. Doesn't matter which one you pick. I kind of like to always use the top one as my base equation. So x is my base variable since it has no operations. It's void of any operations. It's equal to 3 times y plus 9. Now I write the off base. Y equals 2x minus 8. Now remember, when I'm doing this substitution method, that's what this is called. And I use a substitution if I can ever find a variable without any operations. That's on one side of the equation. By the way, when I say without any operations, that means the variable that's on one side of an equation all by itself. That's what I'm talking about when I'm saying no operations. And here we had 2 variables all by themselves on one side, x and y. So I could use either one as a base. I kind of prefer the top. Okay, so I write the equation I'm not using as the base, and 1y and 2x, that's good. Make that 8 plus negative. And we're going to replace that x variable. So 1y equals 2, empty your parentheses, plus negative 8. So 1y equals 2. Now widen your parentheses. And that x will be replaced with 3y plus 9. Okay, now we have to distribute the 2. We got 1y equals, it's going to be 6y plus 18, and don't forget to add the negative 8. Okay, we got y's on opposite sides now, so don't do the adding with the y's. You have to balance the equation. Addition or subtraction property of equality. So 1 minus 6 is negative 5y. And then over here, these are both constants. You don't have a variable attached to either. They're on the same side. So I can do my adding pyramid, just not with the variables. So 18 plus negative 8 is 10. So now I divide both sides of my equation by negative 5. And y equals negative 2. Remember, it's y, so I want to put that for y. Okay, so to solve for x, we're obviously going to want to use the equation where x is all alone by itself. And I have my answer for y. It was negative 2. Y is history. And x equals 3 times negative 2 plus 9. Okay. You really don't want to think about it. 3 times negative 2 plus 9. I got 3. So I can just go put a big fat 3 there. So 3, negative 2. When you're doing the substitution, finding the second answer is very easy. It's finding the first one that's hard. Finding the second one, you should be able to just plug your first answer into the base equation. Okay, I wrote this next one like a moron. I want you to fix something for me. I want you to cross out the second equation and write x equals negative 5y plus 11. Okay. Okay, so again, we're finding our xy solution that would be on both, in part of both of these, or on both lines. Okay, so 8 times x plus 8 times y equals 24. I don't have a variable I can use as my base there. Okay, I got things happening with my variables. But here I have an x all by itself, no operations. So this is going to be where my base equation happens. So I box the x, circle the whole expression it's equal. We're going to use the off base equation. 8x plus 8y equals 24. So the x is by itself, so that's what I'm going to replace. 8, empty it, plus 8y equals 24. Now widen it. 8 wider parentheses plus 8y equals 24. And I will be putting negative 5y plus 11 in that place. Okay, so I distribute. That gives me negative 40y plus 88. Don't forget to add the 8y before you write equals 24. Okay, now we got y's. They're back on the same side, both the same variable. Those are like terms. By the way, if you have an x and a y, they're not like terms. That's why it's so important you be replacing the appropriate variable with the appropriate expression. So that makes negative 32y plus 88 equals 24. Okay, so y is being multiplied there, so I need to undo the plus 88. And 24 minus 88 is negative 60, negative 64, yeah. I know what I was thinking about. Then I divide both sides by negative 32. And that ends up being 2, but it's the y. You got to pay attention to what the variable is. So 2 is my y. Okay, now to find x, I just go into the base equation. Because x is here, ready, screaming, solve me. Here I'll be right. He's crying to be solved. So y is 2. So I multiply negative 5 by 2 because y is no more. Y has been replaced with the answer I found for it, 2. Negative 5 times 2 plus 11. That's going to be 1 because you're going to have negative 10 plus 11. That gives you 1. Okay, now the final problem in substitution. Okay. So Hermson will have this. He'll be writing this. So we got the y here isolated, no operations, so this is where I want to identify the base. Then I write the off base. 5x minus 2y equals negative 35. Again, when you write your off base, you got to make sure the x has a number, the y has a number. If they don't have one, you're going to want to put a 1. I don't need to here, but remember that. Then the minus plus negative. Okay, so y is the variable, that's my base, so I need to get rid of the y. So we have 5x plus negative 2, empty parentheses, equals negative 35. Now let's make the parentheses wider. 5x plus negative 2, negative 35. And I'm going to be putting 6x plus 35. Okay, you got to run a distribution. Negative 2 multiplied by 6x is negative 12x. Negative 2 times 35 would be negative 70. Now, before I just write equals, I have a lot of people that just write equals negative 35. No, you got to add your 5x. Then you can write negative 35. If you get to this point and you have an x and a y, you messed up somewhere. The variables should be the same now. They should appear twice, but they're the same at least. Okay, they're on the same side, so we do our adding. Then I take negative 12, add 5. It's negative 7x. Then we add negative 70 equals negative 35. Okay, so I need to plus 70. Remember, adding a negative is just like minus. You undo it with addition, property of equality. That's 35, so negative 7x equals 35. And then I will be dividing by negative 7. And that gives me my solution of negative 5. So x is negative 5. Okay, to find the y, let's go to the base, because that's where the y is all ready by itself. And I already have my answer for x. I just found it. X now equals, y now equals 6 times negative 5 plus 35. Well, that's negative 30. And if you add 35, it's 5. So negative 5, 5.